Welcome to Prince Math Clinic, the e-learning solution at your pace and time.
Good day, viewers, and welcome once again to class. Today, we shall be discussing this very exciting topic that is involved with what? Circle Theorem. Now, I would not say much because we have all been talking about Circle Theorem from our basic classes. Now, a circle by description is just a shape that is round, and it is not just round, it goes round a particular axis, and every point on the circumference of that circle has equal distance from the center of the circle. That is what makes it a circle, because any point you choose at the circumference, that is at the edge around the circle, has equal distance to the center of the circle. And if you draw a line from the center of the circle to touch any part of the circumference at any point around the circumference of the circle, those points will be equal, and therefore we call such lines radius. On the other way around, if you draw any line that goes from any part of the circumference to touch another part of the circumference, we call that line a chord. And interestingly, when the chord goes through the center of the circle, we call it a special chord, and it has a name called diameter. Now, with that in mind, let us look at some of the theorems in circle theory. The first theory I would like to call our attention to is this. If I have a chord, like I explained, and I have a line from the center of the circle that touches the chord, right? This part of the chord from here to here and from here to here will always be equal, right? Also, the angle that will be here will be 90 degrees, and the angle that will be here will be 90 degrees. That is the first theorem that I would like to expose you to. Remember, if you have a line from the center that touches the chord, it must divide that chord into two equal parts. Then the angle formed, because it is perpendicular to that chord, will be 90 degrees. The second theorem says that the angle at the center is usually 2 times the angle at the circumference. The angle at the center is 2 times the angle at the circumference. Now, if this is the angle at the circumference, right, the angle of this center, at this center here, C, is 2 times of this, right? That means angle C is 2 times of A. That means if A is 20 degrees, it means that C will be 40 degrees. This angle here will be 40 degrees. If A is 20, this will be 40. The same thing with D and B. It means that B will be 2 times of D. So if D, for instance now, right, is 160 degrees, it means that B will be 2 times of angle D, which will be 320 degrees. Is that clear? Good. Then I also want to introduce to you the other part of the theorem, and that theorem is just simple. In a cyclic quadrilateral, if I add my angle A plus my angle D, because they are opposite angles in a cyclic quadrilateral, they are equal to 180 degrees. That means if I have my angle A plus my angle D, they must give me 180 degrees. So therefore, if my angle A, for instance, is 20 degrees, it means that my angle D must be 160 degrees, right? The same way, if I have my angle C and B, If I add these two together, I must get 180 degrees. Also, if I have a circle like this, now remember earlier I talked about a chord. If I draw any line from this point to this point, I form the chord. If I draw any line from this point to this point, I've drawn a chord. If I draw any line from this point to this point, I've drawn a chord. Therefore, any angle I have here and here will be the same. Why is this the same? This chord, let us say this is chord A, this is chord B. Chord A has divided the entire circle into two particular segments. This is the major segment, the small part is the minor segment. So these two angles are in the minor segment, right? Because they are in the same segment, we say they are what? Equal. Likewise, the angles here and here will be the same because this chord B has divided the circle into two segments. This is the major segment, the smaller part is the minor segment. Now, because the two angles belong in the minor segment, we say the angles are equal. The other theorem states that if I have a line that goes through the center of the circle, it divides it into two equal parts. That's the diameter. So any triangle I put here occupies a semicircle. Any triangle here occupies a semicircle because it goes through the diameter, right? Therefore, angle in a semicircle gives us 90 degrees. This angle here is 90 degrees. Therefore, by the time you add this angle plus this angle plus this angle, it must give you 180 degrees. Is that fine? Those are the what? The theorems that I want to expose us to. Therefore, let us now use the knowledge of what I have just explained to solve the set of questions we have on the board. Now, for the first question, we are given that XWZ is 33 degrees. That is, this angle is 33 degrees. We have to find XOZ, that means this angle here. This small angle here. That's what we want to look for. That's the angle we are looking for. And if you observe, this angle is at the center, this is at the circumference. Now, the simple thing you just need to do to find XOZ is that you need to let us know that what? Angle XOZ, right, is equals to 2 times of what? XWZ, this angle. XWZ. You can see angles W here, angle O. Now, what is the reason? Angle at the center is twice that at the circumference. That is the reason. Therefore, XOZ. Now, what is the angle at the circumference? 33. So 2 times 33 degrees will give us 66 degrees. That is the solution to XOZ. Then XYZ. XYZ is this particular angle here. XYZ is this particular angle. Now, how do we find that particular angle? Now, from one of the theorems I expose us to, we know that this angle here and the angle here will be, this angle here will be 2 times of this, because this angle is at the center compared to this angle. So, therefore, we want to find the reflex of this angle is the reflex of XOZ. Reflex XOZ will now be, you know, these two angles, we have found this to be 66. These two angles add up to give you what? 360 degrees, because angle at the center is 360 degrees. So to find XOZ, just simplify, just say you subtract 66 degrees from 360 degrees. So this is 294 degrees. That is what you have at this particular angle. Therefore, you know that what angle at the circumference is half of this one. Therefore, x, y, z is half of reflex 1/2 of reflex what x, o, z. Now, so this means that my x, y, z is half of what is our reflex? It is 294 degrees. Now, let's divide now. This will give us 147 degrees. That is the solution to this particular question. Our answer is what? 147 degrees. Let me stand there so that you can see the solution very well. It's 147 degrees. That brings us to the end of today's class. Kindly check on the description of this video to see the solution to the number 2 question. Thank you for watching this video, and do subscribe to this channel if you have not done so, and click on the like button so that others can get to see this video and we will all have simplified maths together. Thank you very much.